Alright, hey there Pre-Calc kids. Today we are looking at 2.3 exponential functions. So when we looked at linear growth, we realized that it had a constant rate of change. Like if we have 2x plus 3, we know every time x goes up 1, my y will increase by 2. Okay, and that's just what slope means, right? For every 1 to the right, how much do you go up or down by? Now we're going to look at real-world scenarios that deal with percentage changes per unit of time. So they aren't going to be constant. They're going to be exponential. All right, we've already kind of seen this when we did some of our sequences. So what is an exponential function? Well, an exponential function is any function in x that can be written as f of x equals a times b to the x power. You notice our x is the exponent. Okay? So now b has to be a positive real number and greater than 0, because when it becomes negative, some funky stuff happens, which we'll talk about in a little bit. Alright? Okay. Alright, okay. So now the base b is our growth factor. That's our rate, our common ratio like we did in our sequences. And our initial value is a, because b to 0 is 1. So a is our first value, 1, x is 0. Okay. Okay. So now some things we need to keep in mind. If a is greater than 0, so positive, and b is greater than 1, then it will show growth. But now if my b is between 0 and 1, so a decimal or fraction, then it will be a decay, or like being cut in half each time. Alright? So let's take a look at what this actually will do. I'm going to have to zoom out a little bit, make this look. Alright. If you're using your phone, zoom in. If you're using a laptop, even better. Y'all watch videos like this and stuff on laptops. It just is nicer. Trust me. I know some things. Alright, let's graph this piece and then come up with the characteristics. So when I plug in -2 for my x, what's a negative exponent do? Well, it moves on the bottom. Do y'all remember that? So that becomes 1 over 4. Okay. When I plug in -1, it just flips it. I get 1 over 2. When I plug in 0, anything to the 0 is 1. When I plug in 1, anything to the itself, I think you guys get the idea. 2/3 is 8. Alright. Now let's plot this beast and see if we can notice anything. Alright, so when I plug in -2, I got a 4th. Plug in -1/2. Plug in 0, I got 2. Plug in 1, I got 2. Plug in 2, I got 4. I plug in 4, I got 8. Oh. Now, can this become negative? Is there any number I can plug in for x to make it negative? No dice. Oh, geez. Oh, geez. That was bad, but good enough. All right. So wait a second. My domain, is there anything I can't plug in for x? No, I can plug in negative a Brazilian, right? It'll just be a really small number, really close to 0. Can I plug in really big numbers? Yeah, it'll just end up being a really big number. So my domain is from -infinity to infinity. Now my range, I can't get a negative, okay? But I can get really, really close to 0. I can get to like a million zeros and a 1. So that's an asymptote, actually. This graph has an asymptote at y equals 0. Oops, that's a giveaway. That's called a giveaway. So my range is from 0 to infinity. As x approaches infinity, what's my f of x or my y do? So as I go to the right, what's it do? It goes up to infinity. It gets really, really, really big. Now what happens as I go to the left as x approaches -infinity? It gets small, but not infinitely small. It just gets really, really close to 0. It approaches 0. That means I do have an asymptote. I have an asymptote at y equals 0. A horizontal asymptote at y equals 0. Do I have an intercept? Yes. I have a y-intercept at 0, 1, right? And now for concavity. Is this concave up or concave down or neither? Well, it's kind of making a U shape, so that means it's concave up. Okay. Okay. Anything too scary? All right, let's look at example 2 now and identify if something is exponential or not. Well, let's take a look at it. When I look at this, I have a base, it's being taken to a power, x is in my exponent, so that's going to be a yes, right? What's my initial value on this one? What's my a? Remember, it's a times b to the x. For this one, my a is 1, right? I'd have a 1 in front there, an invisible 1. What's my b on this one? What's my rate, my ratio? For this one's 2. So this is yeah, because it is in the form of a times b to the x, right? All right, let's try this one. I have x to the negative 3. Wait a second, you goofy gusset. Do I have an x to my exponent? No. In fact, if I were to simplify, this would be 4 over x to the third. Dude, that's irrational. That's goofy. So, it doesn't have initial value, and it doesn't have a base. All right, let's look at this one. 5 times my grade to the negative x. X is in my exponent. Can I have a negative exponent? I can. So that's a yeah. My initial value on this one, my a, would be 5. My base is e. E is a number in your calculator. You can check it out. So yeah, this is a y equals a times b to the x, right? My b is e, a is 5. That works. That's just flipped, right? The negative x means your graph goes the opposite way. All right. And lastly, I have 3 times 4 to the e. You goofy gusset. I do have an initial value. It's 3 times 4 to the e. That's a number. Plug in your calculator. It's a number. That's just 129.924. That's a constant. It's not even a function. Putting the fun back into function. Spend my time number crunching. All right. All right, let's compute some stuff without a calculator. Time for our brains to work. Oh, this is scary, Mr. Twiggler. We can do it. All right, so I'm going to do 6 times 3 to the 2 plus 1 without a calculator. It's math magic time. So I'm going to do 6 times 3. 2 plus 1 is 3. 3 to the third is 27. Y'all should know that, actually. Not trying to put pressure on you, but you should. 6 times 27 is 162. And that's not so bad. 6 times 7 is 42. 6 times 2 is 12. 2 plus 4 is 6. You can do it out longhand over here too. That's fine. Two, 4. Ta-da. It works either way. We did it. And if you didn't know 3 to the third is 27, 3 squared is 9. 9 times 3, 27. Let's try B. So I'm doing negative 5 times 8 to the 1/3. Remember, like x to the 1/2, square root of x, y'all. So 8 to the 1/3, oopsie, is negative 5 times the third root of 8. Now, what times itself 3 times is 8? Well, it's 2. Because 8's a perfect cube. That's negative 10. All right, this is going to come back and haunt us in a little bit. But this gives us a little start here. All right. Let's look at number 4. Let's make an equation that has the following characteristics. The value of g at 0 is 3, and the output doubles every 1 unit increase. All right. So, oopsie, I have an initial value, don't I? My initial value is 0, 3. So remember, I have a times b to the x, right? A is my initial, so for this one, my initial is 3. Okay. So 3 times. Now, what's my rate? I'm doubling. So how do I double something? I times it by 2. X. So that's my formula. My equation is going to be y equals, or my g of x, depending on how you're writing it. It doesn't matter. 3 times 2 to the x, right? Okay, I can do that. So what's 3 times 2? 6. I'm just plugging 1 in. 3 times 4 is 12. 3 times 8 is 24. And 3 times 16 is 48. I'm just plugging my x's into that equation. Well, I hope this gives us a head start. I hope you enjoyed. Hope you have a great day. Or bye-bye.